Welcome to video 5, scatter plots. Statistical studies are done where data is collected on two variables to establish whether there is a relationship between the two variables. This is called a bivariate data analysis. Data is represented in a scatter plot. Data points, x, y, are plotted on a grid that represent the specific variables. And then scatter plots are analyzed to determine if there is a relationship between these variables. So when we look to determine if there is a correlation, we are always looking for the pattern that is visible in a scatter plot. So for example, if we look at this first one, we can see that generally they're going from a low point, their low x and y value, to a high x and y value. As the x values increase, the y values also increase. Or as the y values decrease, the x values decrease. This is a positive correlation. The next one shows that as x values increase, y values decrease. So as we're going from here, the x value is low, the y value is high, and then it continues to go, x increases but y goes down, or vice versa. This is called a negative correlation. And then we'll have scatter plots where there's really not any visual pattern. There's like a high and low, and they're all over the place. That'll show no correlation, meaning really there isn't a positive or negative relationship there. When analyzing the data, we're looking for the correlation coefficient, and that's the R number. This describes the strength of the relationship between the equation found and the data points. So when we have a positive correlation, the R value will be greater than 0 but less than or equal to 1, and the closer to 1, the stronger the correlation. A negative correlation means the R value is greater than or equal to -1, but less than 0. And the closer to -1, the stronger the correlation. And that's a little bit difficult for people to get right away because the negative seems like it's a small number, but really it's just showing that the correlation is negative. But being close to a -1 is just as strong as being close to +1. The next thing that we'll look at is causation. This is a cause and effect relationship. Two variables can have a strong relationship with one another on a scatter plot, but might not have a causal relationship. A causal relationship exists when the change in one variable actually causes the change in the other. Again, that's called a causal relationship. Exercise 1 says, in each of the following scenarios, two variables are given that, if plotted, would have a strong correlation. We want to determine if there exists a causal relationship between the two variables, and if so, which variable causes the other. So the high temperatures in New York City and the number of bottled waters sold. While higher temperature might have a correlation with the bottles of water going up, this is not actually causal. I said no because the high temperatures does not cause water to be sold. Again, higher temperatures might cause someone to have more thirst, which does in fact increase the number of water bottles sold. It's not causal. B says that a person's weight loss and the number of hours a person spends in the gym per week. I think this one is causal because the hours at the gym do cause the weight loss. So as you're working out, that's causing you to sweat and lose weight. So that does cause the weight to go down. Okay, so this next one says a person's height and a person's shoe size. So the question is, does one cause the other to increase? Well, I'm going to say no, it's not a causal relationship because although as a person gets taller, their shoe size often grows as well, the height is not causing the shoe size to grow. There's a correlation here, but it's not causing the other thing to happen. You can think about this as, somebody might be tall but have a smaller shoe size, or somebody might have their feet grow before their height grows, so they might have a bigger size shoe but not be as tall yet. So it's not causing the shoe size to increase. So I'm just going to say no, and the reason is what we just talked about. The next one, the years of education a person achieves and the salary that person starts at upon entering the workforce. Again, there might be a relationship here where there's a correlation showing that as education increases, the salary also increases. But that does not cause your salary to increase. It might help you to apply for jobs that require a higher salary or a higher education level, which then cause your salary to increase. But number of education years does not automatically cause your salary to increase. We can have people who have gone to school for a long time and have lower paying jobs, or you might have people who decide not to go to school but still have high salaries. So remember that you don't have to go to college just to have a high paying job. So that's why in this situation, I can't say one causes the other. These are tricky. You always just have to think to yourself, is one truly causing the second thing to happen? Or is it just that there's a correlation? There's something that, generally speaking, they do both increase or both decrease depending on the situation. Okay, so hopefully you can fill these in, but we're going to recall the functions that we studied this year. They were linear, exponential, and quadratic. Hopefully you remember what these look like. When we talk about linear functions, they are our straight lines, and they can either be positive slope or a negative slope. We have exponential, growth and decay, so they can be growing or decaying. And we have quadratics, which can be positive, like a smiley face parabola, or negative, like a frowny face parabola, if you make that connection to what we learned previously. So now let's look at what we can do with scatter plots based on patterns. Just make sure that you've sketched in your graphs, at least have a sketch of what they look like so you can recall all those functions, which are very important from what we've learned through the year. The next part says identify what type of function is being modeled by the scatter plots below. So this first one, if we look at the pattern, the scatter plot shows it starts up here and then they kind of go down. They're pretty linear. I mean, there's a few down here that are far off from the line, but generally speaking, as these increase, these decrease. So if we looked at the age 20, the number of cell phone calls is up high, and then for 60, the calls is down low, and that continues to follow that trend. So I'm going to say that this is linear, and it shows that negative because of the negative slope. Now the next one, generally speaking, we start up here, and then it kind of goes down this way. So we can see generally it goes down in this curve-like pattern. So this scatter plot seems to be exponential and it's decaying. And the last one, the scatter plot here, kind of looks quadratic and it's like opening up like a smiley face parabola would. So this is quadratic. And we can see it kind of looks like a happy face parabola, so that's why it's positive. Okay, so hopefully this helps you to recall all the information about functions that you've learned and know how to look at scatter plots. Have a good night.